close to the epsilon。如果说你用把它级数展开的话 ，OK， if you can find out arctangent of epsilon very close to the epsilon，OK。So it become alpha plus epsilon and alpha plus m over c, right? Epsilon equal to m over c. So our lift, instead of using arctangent here, m over c here, we can, for the small camber, can be replaced by m over c because of this. Okay, so this is become m over c here, and so our formula eventually become like this. Our lift can be generated as 4 pi rho u squared c because a is equal to c here. Okay. 40. Okay. Alpha C. Okay. So this is m over c. Okay, can be replace our arctangent epsilon here. So this is lift. And then we also can calculate the lift coefficients. This is the definition of lift coefficients. Okay, so eventually you got this. Okay, 2 pi sine alpha plus 2h over L. Okay, that's it. So as you can see here, okay, if it is h, okay, approach to 0.What happened？ 如果 h 不见了，就是变成 camber 不见了，对，弧度不见了，弧度不见就回到什么？回到 flat plate，okay, reduce to flat plate, right? So h equal to 0 give you 2 pi sine alpha, and 0 will approach to 2 pi sine alpha, will be reduced to flat plate result. Okay, and from this here we also can find out when h is increased, what happened? Sine alpha plus 2h over L is also increased, right? So this is the zero is increased. So h increase, camber increase. Okay, our zero will also increase. Okay, 这也可以从这个，所以 you can also using the air foil. Okay, I just show you the tool. Okay, you can see this tool. Okay.I apply NACA 4418， okay, 这个是它的一个机翼的特殊。In aerodynamics, we have all kind of airfoil, okay, and this is a 4-digit airfoil. 这是四个位数的 airfoil. 你只要告诉它的，它就是某个形状。And 18 here, 18在这个地方代表它的厚度 ，it represent the thickness ratio.That's your T measurement over L. That's 18%. And 44 here give you a camber effect. Okay. So here I think I did. Okay. I would like to compare with the same thickness, but with the camber. I remove it. 我把这个前面这个厚度这个先把它消掉。Okay. As you can see here. I don't have.I forgot to connect. 不见了，没有网络，忘了，希望它还回来。Okay. I think I make a mistake here. Okay. I have to do again. Okay. So I will choose the airfoil NACA 0110. This is all airfoil. You can choose any airfoil shape. Okay. 地方所有的 airfoil 有各种不同的，这是0018. This is one of airfoil I just choose. This is symmetric airfoil. Okay. So this is one airfoil. Okay. So this airfoil look like this. 这是我们的形状。I would like to compare. 先用 compare, okay? Compare with another airfoil, okay? With a camber. NACA with camber. Let me choose one of camber. 同样厚度的，看看有没有同样厚度。 Okay, this is another airfoil with a camber. Okay, so they can compare these two airfoil. One, the red camber, the red airfoil is symmetric. Okay, the orange, or not orange, the green one. Okay, green one, as you can see, the upper surface is higher, lower surface lower is higher. So this is produce a camber effect. 所以这个地方给你的 camber， 这是 camber 9， this is the camber 9 for this airfoil. Right? This is with the camber. And I would like to show you the lift coefficient. Okay, so this is the lift coefficient here. I can compare with the Reynolds number. I just compare with Reynolds number 100,000. Okay, 我把它比较同一个 Reynolds number 就好了，就不用那么多条线，你看，所以我就比较这两个。We can compare with this. Okay, you can see our lift coefficient become like here. Okay, our lift coefficient. This is without camber. This is with camber. Okay. As you can see, the slope. See, the slope didn't change too much. 斜率没有太大的变化。However, for the same angle attack, this is the angle attack. Right? This is our CL. For the same angle attack, without camber, with camber, which is higher? With camber is higher. Right? 可以看得很清楚。And compare with our result here. We can go back to our formula here. Okay? This is the formula we have, right? This is the formula we have. Camber is here. Camber effect is here. Right? Without camber, with camber, slope didn't change. However, the lift CL is increased because what? At a specific angle, because of this additional angle here. Right? Additional angle here, you will produce more lift. Okay? So all the curve is shift upward. 可以看到我们的整个的线是往上移的。OK， 从这个，如果你了解这个 effect 的话，基本上就可以了解为什么这个是往上移。As you can see, for the same lift， 这个是同样的 lift，right？ 同样 lift，OK？ This is alpha plus what? 2h over L already, right? This is alpha only. So that alpha plus camber effect will be the same as only alpha effect. 看听得懂？可以看得到这个效应出来。Okay, so this is the result we have. Okay, right? Without camber, we have to all based on alpha. Right? So with the camber, we can have a small alpha plus this additional alpha can produce the same lift. Okay, so that's why I mentioned here. Okay, so that's a camber effect. Okay, so this is due to the camber. Okay, we can have more lift because of camber. Okay, finally, okay, I would like to close this chapter today. Okay, this is very tedious. Okay, we know how to generate the thickness already, right? By move the circle to the left, 对，我们可以把一个 circle 往左移，就可以增加厚度。By move the circle upward in y direction, we will generate camber. If we want to have an airfoil with both thickness and the camber, what should we do? Move to the second. So we have to move. Okay, instead of our circle origin at here, we have to move here, right? Move to here. To the left, give you the thickness. To the upward, give you the camber. Okay, that's the main idea.
Okay, so once you do that, through a Jacobi transformation, you will generate the L Fourier, Jacobi L Fourier with the thickness as well as with the camber. Okay, so that's it. Okay, so this is a final geometry look like for this geometry of a surface. Okay, you can calculate. Okay, also you can superimpose to later I can show you how to do that. Okay, so once you know that this L Fourier geometry with a camber effect, this is a thickness effect here, right? This is thickness effect here with a camber effect here. Okay, H is a camber, and this is our thickness effect here. Okay. So here is a kind of we can superimpose. Okay, we know how to write down the equation for the Jacobi with camber only. This is Jacobi L Fourier with camber effect. This is Jacobi L Fourier with a thickness effect here. Okay, so we can superimpose together. Okay, if you want to know with the thickness effect as well as with the camber effect, this is the final result. Okay, as you can see, y is equal to this. This is our thickness effect. Will be exactly the same here, right? Positive, negative for this value. This will give you the y location. And what's this? This gives you the if you change here, y is equal to what? Y is equal to this number, right? This number is here, right? With a camber effect, this number minus s squared, and then take a square root, right? Take a square root here, and then minus this, right? So give you this y already, and this y plus this with a thickness effect will be superimposed together, give you with the L Fourier with thickness with camber. Okay, so that's a coordinate. Okay, we have, if you base on your core length and the camber and also and so that's the Jacobi L Fourier equation. Okay, and how do you get this? Just you have to flow over cylinder. For cylinder is like this. Okay, 你的 cylinder 要变成这样，你圆心要在这里，就会得到同样，就会同到。Okay, next, we would like to know the lift, okay, with a camber as well as with a thickness effect. So lift coefficient, flat plate is 2 pi sine alpha, right? This is flat plate. 我这个地方把这个移进来一点 ，okay. 所以这个是2 pi sine alpha give you the lift, okay. 2 pi sine alpha is a reference, okay? It's flow over a flat plate with angle attack alpha. Okay? With a camber effect, this is a lift coefficient we got 2 pi sine alpha plus 2h over L. So the alpha here changed to this. With the thickness effect, our slope is changed, right? It become 2 pi 1 plus 0.77 T measurement over L. This is thickness effect with angle attack alpha. You can also predict with the thickness as well as camber effect will look like this. Okay, 2 pi for this and alpha here change to this. Okay, this is with a thickness effect as well with what? With a camber effect. 所以最后的结果我们不用去计算，我们都可以去superimpose。Okay, 这个地方 ，this is the L Fourier. Okay. With thickness effect as well as a camber effect in the lift coefficients. Okay. 好 Finally, complete potential, flow field. We know the geometry, we like to know the flow field. Okay? So flow field, as you can see here, this is the complete potential for this. Okay, for this flow over a cylinder with the origin at this location, and this is what? zeta minus Im because our origin of this circle changed to Im. So become zeta minus Im. All the zeta location becomes zeta minus Im. Okay? And what's this? This is a thickness effect. Move to the left. Okay. So this is a okay, complete potential. Look like this. Okay. Finally, our location will be moved to here, right? With M. And so this is this distance from here to here is M. However, this location is MEI delta, right? Yeah. So this location, so our location for this original will change to delta minus MEI delta. Okay, MEI delta. Okay, so that's a complete potential for this flow field. Okay. So location is different, right? Location is different. Okay. How about the gamma? Okay, gamma have to be satisfied what? Coulomb condition, right? Coulomb condition. So here the gammas change a little bit. Alpha plus this, right? So this is alpha plus this give you the gammas. The Coulomb, in order to satisfy Coulomb condition, our stagnation point have to move. Instead of alpha angle, have to alpha plus this angle. This is the angle we have with a Canberra effect, right? And this didn't change. And so here we only change what? Change only the thickness here. This is a circulation here. Okay. This is a thickness effect. Okay. The circulation due to a thickness effect, and also the circulation due to the Canberra effect is from here. So this is finally with a thickness with a Canberra, how much circulation we should have. Okay, so you can superimpose together, okay, give you the circulation. So gamma here, for this flow field, flow over the Jokosi airfoil with the thickness and Canberra effect. So this, okay, the gamma here should be using this. Okay, in order to satisfy our Coulomb condition. Okay, I think that the complete potential. Okay, so after that, you just go through, plug in the Jokosi transformation, you can find out the complete potential for in the Z plane. Okay, so I don't think we need to do that because it's already very complicated. So zeta here can be changed by using the formula like this. Let me show you. Finally here, zeta. Where is that? I didn't find it. 不见了。刚刚有个公式在哪里 ？Z 等于什么？哦，这里 zeta equal to this, right? So by apply this, okay, zeta equal to this into all the formula here, you can get the final, okay, yeah, change it here, okay, you can get the complete potential for this. Okay, now we conclude, okay, the chapter 4. Okay. 好，那我们第4章我们就这样结束了 ，OK。第4章最长的，也最多很多小的一些数学。Okay, so we may have the homework for the chapter 4. Okay, I will put on the website today or tomorrow. Okay, so I think it will be next Thursday. Okay, instead of Tuesday, next Thursday. We will turn in our homework for the chapter 4. Okay. 好，那我们大概今天上课先上到这里，回去看一下第4章的东西。OK。我们在这个礼拜再做一些homework。OK。所以下礼拜4我们再交那个homework。